factorise these things. So when there is a number in front, it's a little bit more complicated. It's not just going to be x and x. Okay? I know that this 2x is still sitting here. Alright? So this is a whole procedure how we do this. We multiply the first and the last number. We have 2. We need to find two numbers that multiply to get this number and add to get this -3. Now, the only way of multiplying numbers together to get a positive value here and a negative value when you add them is if they are both negative. So my two numbers are going to be -2x and -1x.
That makes sense.
Okay? Are you happy with that so far?
We're doing this if we can't get two numbers.
Well, because if it was just x squared plus 5x plus 6, okay, we know it's just going to be x and 3 and 2. Okay, easy, nice, easy, because we've just got x here. But this one has a 2x squared, so this makes it more complicated.
Oh.
So this is the procedure we go through when we factorize expressions like this.
So why do we keep the +1?
Because all we've done is, rather than writing 2x squared minus 3x plus 1, I've split this into these two terms here.
Yeah.
So this process is called splitting the middle term usually. Okay? So what we've done is, no clues for why we call it this, we've split the middle term, okay, into two numbers. What? We then cut that expression in half. Okay, so we cut it in half. This 0 is still here, this 2x is still here. Right, what's common to this left-hand side? 2x. And so we open up our bracket and we're left with x minus 1. Okay. Now this is where most people start to go a little bit. Yes, the bracket has to be the same as here. So this bracket has to be, oh, that's not the same. This bracket has to be the same as the other brackets. So I have to look at these things over here and say, well, what must be at the front of that bracket for both of these two signs to have changed? -1 and -1. Yeah, she did. Alright, so let's just look at this again. We split the middle term, we had 2x squared minus 2x, we saw that 2x was common, and we were left with x minus 1.
Oh, okay.
I know I have to have x minus 1 in my other bracket, otherwise the next bit's not going to work. Okay? So, and what's happened is that this was minus x plus 1, and now it's x minus 1. So both signs have changed.
Why?
Well, they have changed, so we say to ourselves, how have we made them change? Well, we must be factorizing by -1.
I know.
Yes?
Yep.
Alright, so now here what I've got is I've got this bracket that's common. Yes? So that's one of my brackets, and then 2x minus 1 must be the other bracket.
This is a lot.
Alright, so now we've fully factorized this thing. Now what that means is that we've got 3. Now remember I said that the number of stationary points tends to be 1 less than the power. So we started off with x to the power 4. So it means we're going to have 3 stationary points. One of them is when this is equal to 0. So that means that x is equal to 0 is one of them. One of them is when this is equal to 0. So x equals 1 is another one. And then what does this one give me? 9. Because if we said that 2x minus 1 is equal to 0, yeah, it's always the opposite value of this over that. So they are our 3, that's where our 3 stationary values occur.
Why do you have 3 now?
Now, what does it say? Do we have to find them all?
Determine their nature.
Should we just pretend we're not
Let's just
finding
toss
them?
it out.
Let's just not find them. We'll just find when they occur. When the stationary points occur. That doesn't make sense. What I'm doing, but you know, because we know what to do. We just stick them into this original. Yes. Yes, you would all do that anyway.
Yeah. Wait, so why do we have 3 X? How do you think?
Because we knew we started off with extra power 4. You generally have one less than the power.
Okay.
Okay?
So like that's how you know if you did it right or wrong, depends on how many you did. Yeah.
Alright, so, but we do need to determine their nature. We do need, we need to determine their nature, so we need to find the second derivative. So, I can't remember what it was. What's the original function?
4x cubed minus 6.
Alright, so let's find the second derivative. We need to find the second derivative. Ali, will you be able to help me out finding the second derivative, please?
12x squared minus 12x.
Okay? Trivias? No, what's that?
Yeah, I'm so confused why we have that 3 values back.
Okay, because the previous example was a cubic, yes? That tends to mean that we're going to have 2 values. So we always have one less than this power. So because this was a quartic, we have 4, means it's going to be probably 3. Okay, you always go down 1. Now, yeah, no, I'm going to keep going. So I found my second derivative, so what am I going to do to find out what kind of points they are? I'm going to stick those values in, yes? So when x is 0, and the second derivative is 0. When x is 1, and that's 0 as well, isn't it? Yeah, right. And when x is 1/2 is 12 lots of 1/2 squared minus 12 lots of 1/2. So that's a quarter is 3 minus 6, which is negative 3. So this one here is a maximum point. And these two we would have to investigate further. We'll talk about investigating further later.
Isn't it plus 2? The derivative?
Oh, I don't know. I need to check.
Just plus 2. Wait, what?
Yeah.
No. Wow.
Ali, I think Ali.
The first derivative is plus 2x.
Oh, you little rascal.
I done wrote it. Wait, derivative is plus 2 minus 6. What happened? Oh. Okay. Because they are related versions.
Yes, it is.
So let's just go back, double check up here. Because our first derivative was 4x cubed minus 6x squared plus 2x. And we just lost this little term here, so we should have had plus 2. Should have had. Oh, should have had 7. So the second derivative here would have been 2. The second derivative here would have been 2. And this bad boy was negative 3. So these two were minimum points, and this was a maximum point.
What are those ends in the circle?
I thought that's when they were was equal to 0. But they're not, so we don't have to worry about that.
Yeah.
Here's some more examples. We don't write anything, thankfully, it's all written there for you. So find the coordinates of any station points on that curve, blah blah. So we've differentiated it. We put it equal to 0. Factorized it, got our 2 solutions. So we're finding the nature. So we know that it happens here. Here we've got our table of values. We know that at those 2 positions there's 0. Here it's negative, sorry, positive, negative, positive. So it must do that. Press the ends. So this is when they're putting they're finding the y values. Lovely jubbly. So they found the coordinates. This example, they found the y values afterwards. Nature of the point, claim methods, la la la, la la la, la la la. We just talked about that. Oh, now here. Yeah, I am. La la la. So this one here, we found that this, when x was 0, the second derivative was 0. So we think it's a point of inflection, so we just need to double check. So this is where you have to go back to those tables we were just talking about. So we look a little bit to the left, a little bit to the right. If it's a little bit to the left, it was positive. A little bit to the right, it was also positive. So that shows us it's a point of inflection. So if it does that, it's a point of inflection. Oh, do you know what? I want to pause it here.